So remember, the ideal gas law reads PV equals nRT, where we have pressure times volume equals the number of moles times the gas law constant times temperature. And our gas law constant, R, is 0.08206 liters times atmospheres per mole times Kelvin. Okay, so if we have our units in something similar to liters, atmospheres, moles, and Kelvin, then we're going to use this form of R. We will see a problem at the end of the chapter where we're going to have R in energy units, so obviously it will have a slightly different number. So the question reads, calculate the volume occupied by 0.845 moles of nitrogen gas at a pressure of 1.37 atmospheres and a temperature of 315 Kelvin. So you can see here that we're given N is equal to 0.845 moles. Pressure is equal to 1.37 atmospheres. And temperature is equal to 315 Kelvin. So be sure to check your units every time and make sure they match the units in the gas law constant R. Okay, and so we were asked to find the volume. Okay, so we have pressure, we have temperature, we have number of moles, and we have R, so we can calculate volume. We just need to solve for V. So from our equation, PV equals nRT, we can divide by P, divide both sides by P, and we get V equals nRT over P. We didn't even need to do any conversions this time. So we plug everything in, 0.845 moles times 0.08206 liters atmospheres per mole Kelvin, that's our R, okay, times 315 Kelvin, divided by 1.37 atmospheres, and we find our volume is 15.9 liters. All right, so let's work the 4 practice problem. An 8.50 liter tire contains 0.552 moles of gas at a temperature of 305 Kelvin. What is the pressure in atmospheres and psi of the gas in the tire? Okay, so we need to find the pressure in atmospheres and then we'll convert it to psi. So our equation is PV equals nRT. So we can solve for P by dividing both sides by V. P is equal to nRT over V. And that we can just plug everything in directly. We don't need to make any conversions here to match our R. So that's 0.0552 moles times 0.08206 liters atmospheres per mole Kelvin times 305 Kelvin divided by 8.50 liters, and that's equal to 1.6254 atmospheres, and that's equal to 1.63 atmospheres because we started with 3 significant figures. Okay. Now we have the pressure in atmospheres, and we need to convert it now to psi. So what we need to do is just start with our 1 point, and I'm going to go back to our bigger number, which was 1.6254 to prevent losing some accuracy there. So we have 14.7 psi is 1 atmosphere. So that gives us 23.9 psi.